Hello and welcome. I am Sakura Swan, your instructional architect. It is my privilege to guide you through this master course on the control hierarchy, a framework designed to build more reliable, purposeful, and effective AI systems. We will proceed at a beginner level, focusing on building a strong foundational understanding of the what and the why, using simple language and clear analogies. Let us begin with our first module. Module 1, Understanding the Foundation, Strategic Intent, and Guiding Principles. This first module introduces the highest layer of the control hierarchy. We will explore an AI's core purpose and the non-negotiable rules that guide its every action, ensuring it stays true to its mission. Welcome to Lesson 1.1, Defining Strategic Intent. Imagine you are the captain of a ship. Before you can hire a crew, plot a course, or even raise the sails, you must answer one fundamental question. Where are we going? Without a destination, your ship is just an aimless vessel, drifting at the mercy of the waves. In the world of AI, strategic intent is that destination. It is the single most important decision you will make because it defines the AI's ultimate purpose and reason for existing. Our learning objective for this lesson is to define strategic intent within the context of AI system design and identify its role as the ultimate why and North Star. In this lesson, we will break down what strategic intent is, why it's the critical first step in creating any AI system, and how it serves as the ultimate guide for every decision that follows. So what is strategic intent? Strategic intent is the North Star for an AI system. It is a clear, high-level statement that declares the AI's core purpose, its unique value, and what it ultimately aims to achieve. It answers the big questions. Why does this AI exist? What future will it help create? And what makes it different and valuable? Every single component of an AI, from its personality to the code it runs, must serve its strategic intent. A clear intent acts as a filter. If a proposed new feature doesn't align with the AI's core purpose, you discard it. This prevents the AI from becoming a confusing, unfocused system that tries to do everything and accomplishes nothing. It ensures all development and actions are purposeful. For example, let's consider a health and fitness AI. A weak intent would be an AI to help with fitness. This is far too broad. A strong strategic intent would be to empower individuals with sedentary lifestyles to build sustainable, healthy habits by providing encouraging, simple, and science-backed daily challenges. This is a perfect North Star. We know exactly who it's for, what it does, and how it does it. Now that we've laid the theoretical groundwork, it's time to solidify your understanding. Here is an activity. Let's consider a hypothetical AI assistant designed to help children learn to read. Brainstorm a strong strategic intent for this AI. Don't just say to help kids read. Think about its specific mission, the future it helps create, and what makes it unique. Write a 1 to 2 sentence statement. An excellent strategic intent for this AI could be to foster a lifelong love of reading in early learners, ages 5 to 7, by transforming story time into an interactive adventure where the child becomes the hero of the narrative. This statement clearly defines the audience, the unique method, and the aspirational goal. Excellent. To conclude this lesson, let's move to a brief assessment. In your own words, explain how a clear strategic intent prevents an AI system from deviating from its core purpose over time. A clear strategic intent acts as a permanent guidepost for all decisions. When developers consider adding a new feature or changing the AI's behavior, they must ask if the change serves the core purpose. For the health AI, if someone suggested adding a feature to track stock prices, the team would immediately reject it because it doesn't align with the intent of empowering healthy habits. This ensures the AI remains focused, effective, and true to its mission, preventing feature creep and a diluted user experience. Welcome to Lesson 1.2, Identifying Guiding Principles. Continuing our ship analogy, once you have your destination, your strategic intent, you need your navigational rules. These are the non-negotiable principles you follow on your journey. Always prioritize the safety of the crew. Never sail into a known storm. Conserve fresh water. These rules, or guiding principles, ensure you not only reach your destination, but do so in the right way. Our learning objective is to identify examples of guiding principles that enforce strategic intent, such as ethical guidelines and business objectives. In this lesson, we will define guiding principles, understand how they flow directly from the strategic intent, and explore different types of principles that are essential for controlling an AI's behavior. So, what are guiding principles? They are the core rules and values that an AI must always obey. They are the practical application of the high-level strategic intent. If the intent is the what, the principles are the how we must behave. Good principles are actionable, meaning they clearly guide behavior. They are non-negotiable, meaning they cannot be broken, and they are derived directly from the strategic intent. Let's look at a few types using our health AI example. First, ethical principles, which relate to fairness and safety. For instance, never give medical advice. Always refer users to a doctor. Second, operational principles, which relate to performance and personality. For example, always use an encouraging and positive tone. And third, business principles, which relate to organizational goals. An example might be, subtly highlight the benefits of the premium subscription after a user completes a 7-day streak. Now, let's practice. Look back at the strategic intent we created for the Learn to Read AI, to foster a lifelong love of reading in early learners by transforming storytime into an interactive adventure. Now propose 3 non-negotiable guiding principles for it. Include at least 1 ethical and 1 operational principle. Here are 3 strong guiding principles for that AI. An ethical principle: ensure all content is age-appropriate and free of commercial advertising. An operational principle: celebrate progress and effort over perfect pronunciation to build confidence. A second operational principle: keep all interactive sessions under 10 minutes to match a young child's attention span. Excellent work! For your final assessment in this lesson, what are the 2 most important characteristics of an effective guiding principle, and why are they crucial? The 2 most important characteristics are being actionable and non-negotiable. A principle must be actionable so the AI and its developers can clearly understand how to apply it. Be helpful is vague, but provide a definition for any word the user struggles with is a clear action. A principle must be non-negotiable to ensure the AI remains safe and aligned with its core purpose, even in unexpected situations. It acts as a hard boundary that prevents the AI from making critical mistakes. You have now successfully completed the first module. You understand how to define an AI's ultimate purpose through strategic intent and the core rules that govern its behavior through guiding principles. Module 2: Building the Blueprint, Meta Protocol and System Architecture. This module explores how we turn our big ideas for Module 1 into a functional plan. We'll learn how to create the master rules for making rules and sketch out the AI's basic operational structure. Welcome to Lesson 2.1, Grasping Meta Protocols. You have your ship's destination, strategic intent, and your captain's rules, guiding principles. Now you need to write the shipbuilder's manual. This manual doesn't describe every nail and plank. Instead, it sets the overall design rules. The ship must have 3 masts. The hull must be made of oak. A meta protocol is this shipbuilder's manual for our AI. It's the foundational blueprint that dictates the AI's fundamental structure and capabilities. Our learning objective is to explain what a meta protocol is and how it establishes the overarching structure and permissible operations for an AI system. We'll define meta protocol in simple terms, look at how it works using the example of a system prompt, and understand why it's the bridge between our abstract ideas and the AI's actual technical plan. A meta protocol is the set of rules from making rules. It's a foundational instruction set that tells the AI how to behave before it receives any specific user request. It defines the AI's role, its boundaries, and the tools it is allowed to use. A common example is the system prompt. This is a special, hidden instruction that the AI always sees. For a translator AI, the system prompt might be, "You are a professional translator. You will receive text in one language and must translate it accurately into another. Do not add your own opinions or jokes." This meta protocol ensures that no matter what the user asks, the AI always acts within the boundaries of a professional translator. It is the first step in turning our abstract ideas into a concrete technical plan. Time for an activity. Imagine you are creating a simple recipe finder AI. Write a short, simple meta protocol or system prompt for it. Think about its role, what it should do, and what it should not do. A good meta protocol for this AI would be, you are the recipe finder bot. Your role is to find recipes based on the ingredients provided by the user. You will list the recipe steps clearly. You will not provide nutritional advice or medical dietary guidance. To conclude, our assessment. In your own words, what is a meta protocol and why is it important? A meta protocol is a master set of instructions that tells an AI its fundamental job and rules before it even starts working on a task. It's important because it acts like a blueprint, ensuring the AI behaves consistently and stays within its intended role, which directly enforces the strategic intent we defined earlier. Welcome to Lesson 2.2, Understanding System Architecture. Your shipbuilder's manual, the meta protocol, is complete. Now it's time to sketch the ship's layout. This sketch is the system architecture. It shows the main parts of the ship, the deck, the kitchen, the navigation room, and how they connect. For an AI, the system architecture is a simple diagram showing its main functional parts and how they talk to each other. Our learning objective is to describe the role of system architecture in translating meta protocols into a foundational design. We will learn what system architecture means, see a simple example of how different modules can work together, and understand how they communicate. System architecture is a high-level map of the AI's main components or modules. Instead of one giant, messy brain, it's often better to design an AI with several specialized, smaller brains that work together. A simple model is the thinker-doer. Imagine an AI designed to answer complex questions. The planner module is the thinker. It receives the question and breaks it down into small steps. The worker module is the doer. It receives the plan and executes each step, like searching the web, to assemble the final answer. These modules communicate through pathways called APIs, or Application Programming Interfaces. Think of an API as a very strict waiter. The planner writes its plan on a specific order form, the API request, and the worker takes the form, does the work, and returns the result on a specific tray, the API response.
This ensures communication is orderly and predictable. Let's try an activity. Design a simple architecture for our Recipe Finder AI from the last lesson. What 2 simple modules could it have? Give them names and describe in one sentence what each part would do. An effective and simple architecture could be Module 1, the ingredient parser. Its job is to identify and list the valid food ingredients from the user's messy, natural language input. Module 2, the recipe database searcher. Its job is to take the clean list of ingredients from the parser and search a database to find matching recipes. For our final assessment, why is it often better to build an AI with several small, specialized modules instead of one big brain? It's better because it makes the whole system more organized and easier to manage. Each part has one clear job. If the AI makes a mistake, you know exactly which module to check and fix. It's like having a team of specialists instead of one person trying to do everything. It's more efficient and reliable.
Module 3. Activating the AI, Persona and Core Directives. Now that we have the blueprint, it's time to give our AI a personality and a clear mission for specific tasks. This module is about breathing life and purpose into the structure we've built. Welcome to Lesson 3.1, The Role of Persona in AI. Imagine you're hiring an actor. Your script, the meta protocol, and stage design, the architecture, are ready. But who is the main character? Are they a wise old professor, a witty comedian, or a cautious librarian? This character choice is the AI's persona. The persona doesn't change the script's words, but it dramatically changes how those words are delivered, influencing the entire feel of the performance. Our learning objective is to explain how assigning a persona to an AI influences its behavior, expertise, and communication style for a specific task domain. We'll define what a persona is, explore how it shapes the AI's tone and style, and see how different personas can make the same underlying technology feel completely different to the user. An AI persona is a carefully crafted personality that dictates the AI's tone of voice, style of communication, and apparent expertise. Persona makes the AI feel more natural and intuitive. A user talking to a financial advisor AI expects a serious, data-driven tone. If they were talking to a creative writing coach AI, they would expect an encouraging and imaginative tone. The right persona builds user trust. For example, imagine one general AI model given 2 different personas. Persona 1, the tutor, is instructed, "You are a patient and friendly tutor. Explain concepts simply." This AI will break down topics and use analogies. Persona 2, the debater, is instructed, "You are a sharp and critical debater. Challenge the user's assumptions." This AI will be analytical and focus on finding weaknesses in arguments. The underlying technology is the same, but the persona creates a completely different user experience. Now for an activity. Think about an AI designed to help people plan their vacation. Describe a good persona for this AI. What should its tone be? What kind of personality would make you trust it with your travel plans? A great persona for a travel planning AI would be the enthusiastic organizer. Its tone should be upbeat and reassuring. Its personality would be meticulous and detail-oriented, but also adventurous and inspiring, making you feel confident that every aspect of your trip is handled while also getting you excited about the possibilities. To conclude this lesson, your assessment. Explain why giving a tutor persona and a debater persona to the same AI would result in 2 very different answers to the question, what is the best form of government?
The tutor persona would give a balanced, neutral answer. It would explain different forms of government, list their pros and cons in simple terms, and might ask the user what they think. The debater persona would likely take a strong stance, arguing for one form of government over another. It would use assertive language and try to win the argument, creating a much more confrontational experience.
Welcome to Lesson 3.2, Crafting Core Directives. Our actor now has their character, their persona. The final step before they go on stage is for the director to give them one last crucial instruction. In this scene, your main goal is to make the audience laugh. This instruction is the core directive. It's the AI's primary mission for the immediate task at hand. It's the verb, the action it needs to accomplish. Our learning objective is to formulate effective core directives that provide an AI with a clear, high-level operational mandate for a given task. A core directive is a specific task-level command that tells the AI what its primary objective is right now. While the strategic intent is the AI's life mission, a core directive is its mission for the next 5 minutes. It is always action-oriented. For example, a guiding principle is a permanent rule: never give medical advice. A core directive is a temporary task: analyze this user's workout log and identify patterns. The AI must follow its directive while obeying all its principles. An effective directive is clear and specific. Help the user with their email is too vague. A good directive would be: read the following email thread and generate a 3-bullet-point summary of the key decisions made. Let's do an activity. You have an AI with a professional chef persona. A user uploads a picture of the ingredients they have: chicken, broccoli, and rice. Write a clear, action-oriented core directive for the AI for this specific task. A strong core directive would be: generate a simple, step-by-step recipe using only chicken, broccoli, and rice that can be prepared in under 30 minutes. Provide a title for the recipe and a list of kitchen tools required. For your assessment, what is the main difference between a guiding principle and a core directive? A guiding principle is a permanent, high-level rule that the AI must always follow, like a law. A core directive is a temporary, specific task or command for the current situation. The AI must complete its directive without ever breaking its principles.
Module 4, Executing the Plan, Operational Protocols and Workflows. This module gets into the nitty-gritty. We have our mission and personality. Now, how does the AI actually think? We'll explore the step-by-step reasoning patterns an AI uses to get from a question to an answer. Welcome to Lesson 4.1, Exploring Operational Protocols. Imagine you have to solve a math problem. You wouldn't just guess the answer. You'd follow a process. Write down the knowns, identify the formula, plug in the numbers, and solve. This step-by-step process is an operational protocol. It's a structured way of thinking that helps AIs solve complex problems. Our learning objective is to identify a common operational protocol used by AI, such as chain of thought. An operational protocol is a recipe for thinking. One of the most important protocols is chain of thought, which can be explained with the simple instruction, think step by step. This forces the AI to first write down its internal monologue before giving the final answer. For example, for the problem, what is the total cost of 3 apples at $0.50 each and 2 bananas at $0.75 each, with chain of thought, the AI would first reason, first, I need to calculate the cost of the apples. That's 3 times 0.50, which is 1.50. Next, I need to calculate the cost of the bananas. That's 2 times 0.75, which is 1.50. Finally, I need to add the two costs together. 1.50 plus 1.50 is 3.0. Therefore, the final answer is 3.0. By forcing it to show its work, we help the AI self-correct and arrive at the right answer more often. Time for an activity. Imagine you ask an AI, I have 5 shirts and 3 pairs of pants. How many different outfits can I make? Using the chain of thought protocol, write out the simple, step-by-step reasoning the AI should follow. The AI's chain of thought would be, Step 1, identify the number of shirts, which is 5. Step 2, identify the number of pants, which is 3.
Step 3. To find the total number of unique combinations, I must multiply the number of shirts by the number of pants. Step 4. 5 multiplied by 3 equals 15. Therefore, I can make 15 different outfits. For your assessment, why is telling an AI to think step by step more effective for complex problems than just asking for the final answer? It's more effective because it forces the AI to break a big, complex problem down into smaller, simpler steps. This reduces the chance of making a mistake. It also allows us to see the AI's reasoning, so if the final answer is wrong, we can easily see which step in its logic was incorrect.
Welcome to Lesson 4.2, Understanding Basic Workflows. Sometimes thinking isn't enough. Imagine you ask a friend, "Who won the baseball game last night?" Your friend follows a simple workflow. 1. Realize they don't know the answer, reason. 2. Pull out their phone and search for the score. Act. This reason then act sequence is a fundamental workflow for AI, allowing it to use tools to overcome its knowledge limitations. Our learning objective is to describe a basic workflow for AI task execution that involves using an external tool. A workflow is a predefined sequence of steps that combines reasoning and acting. A simple but powerful workflow is called React. First, the AI reasons about the user's request. It decides if it knows the answer or needs a tool. Second, it acts, triggering an external tool like a web search or calculator. Third, it observes the result from the tool. Finally, it reasons again to formulate the final answer. For the question, "What is the weather in Tokyo right now?" the AI reasons that its knowledge is not current and it needs a tool. It acts by calling a weather app. It observes the result, 25 degrees Celsius and sunny, and then formulates the final answer. Let's try an activity. A user asks an AI, "What is 15% of $500? Outline the simple React workflow the AI would use to answer this. The workflow would be: reason, the user is asking for a precise calculation. To ensure accuracy, I should use a calculator tool. Act, call the calculator tool with the input 0.15 times 500. Observe, the tool returns the result 75. Reason, I have the correct answer and can now present it to the user. The final answer is 15% of $500 is $75. And the assessment. Why is a workflow like React a major advancement over an AI that can only write text? React is a major advancement because it allows the AI to overcome its limitations. An AI that can only write text can't know real-time information. By using the Reason-Act workflow, the AI can identify gaps in its own knowledge and then use external tools to find the correct information, making it much more powerful and useful. Module 5. Managing Information. Data and Context Management. An AI is only as good as the information it has access to. This module covers how an AI takes in, remembers, and prioritizes the different types of data it needs to function. Welcome to Lesson 5.1, Understanding Data Ingestion. Think of a chef preparing a meal. They have ingredients from many sources: fresh vegetables from the garden, real-time data, spices from the pantry, stored knowledge, and the customer's specific order, the user query. The chef must gather, or ingest, all these different types of information. An AI is just like this chef. Our learning objective is to describe the various sources of data an AI can ingest, including external tools, memory, and user queries. Data ingestion is the process of an AI collecting the information it needs to function. The three main sources are the user query, the user's direct command, like "write me a poem," memory. This includes the conversation history and the vast library of pre-trained knowledge the AI was built on. External tools.
This is fresh, real-time data from web searches or other APIs. The AI's final response is a blend of all these sources. Here is your activity. A user asks their phone's AI assistant, "Remind me to call mom when I get home." List the 3 different types of data the AI might need to ingest to fulfill this request successfully. The 3 data types are user query, the explicit command, "Remind me to call mom when I get home." Memory, the AI needs access to stored data that defines the location of home and the contact information for mom. External tool, it needs real-time GPS data from the phone's location service to know when the user has physically arrived at home. For your assessment, what are the 3 main sources of data an AI ingests? And give a simple example of each. The 3 main sources are user query, the user's direct command. For example, "What's the capital of Japan?" Memory, the AI's stored knowledge. For example, its pre-trained knowledge that Tokyo is the capital. External tools, it fetches real-time data. For example, using a weather API to find out it's currently raining in Tokyo.
Welcome to Lesson 5.2, Context Window Management. Imagine you're talking to a friend who can only remember the last 2 sentences you said. You'd have a very frustrating conversation. This memory limit is exactly what an AI has, and it's called the context window. Our learning objective is to explain the concept of a context window and its importance in managing the information available to an LLM at any given moment. The context window is the maximum amount of information an AI can see or remember at one time. This includes the user's query, the recent conversation history, and any data from tools. It's measured in tokens or pieces of words. Once a conversation exceeds this limit, the AI starts to forget the beginning of the conversation. This is a major challenge. Because the space is so valuable, a key part of AI design is context window management, developing strategies to decide what information is most important to keep in the window. Here's your activity. You're having a long conversation with an AI about planning a vacation. You've discussed destinations, budgets, and activities. Now you ask, based on everything we've talked about, which of those 2 cities is the cheaper option? If the AI's context window is too small, what specific information might it have forgotten? If the context window is too small, the AI has likely forgotten the specific budget figures or price ranges that were discussed at the beginning of the conversation. Without that crucial data, it cannot perform the comparison and answer the question correctly. And the assessment. In simple terms, what is an AI's context window, and what is one problem it can cause in a long conversation? An AI's context window is its short-term memory, the maximum amount of text it can look at once. A major problem this causes in long conversations is that the AI can forget what was said at the beginning because the early messages get pushed out of its limited memory space, making it seem like it has lost the plot. Module 6, the core action. Atomic execution and tool invocation. We've reached the very bottom of the hierarchy, the most fundamental action an AI takes. This module is about the engine's piston firing, the simple core process of generating the next word and calling for help when needed. Welcome to Lesson 6.1, the nature of atomic execution. Imagine a painter creating a masterpiece. From afar, you see a beautiful landscape, but if you zoom in, you see that the entire painting is made of thousands of tiny, individual brushstrokes. The AI's equivalent of a single brushstroke is called atomic execution, the fundamental act of predicting and generating just one single word, or token. Our learning objective is to describe atomic execution as the LLM's fundamental function of generating tokens based on prompt and context. At its absolute core, a large language model is a next token predictor. Atomic execution is the process where the AI looks at all the text in its context window and performs one single indivisible action. It calculates the most probable next token to add to the sequence. The sentence, "The cat sat on the mat," is not generated all at once.
the AI predicts the, then cat, then sat, and so on. Every complex paragraph is simply the result of thousands of these tiny atomic predictions chained together. For your activity, complete the following sentence by predicting the most probable next word. Twinkle, twinkle, little blank. Now do the same for the new Marvel movie was absolutely blank. The most statistically likely completion for the first sentence is, of course, star. For the second, context suggests a strong, evaluative adjective. A highly probable word would be amazing or incredible. This shows how context influences the atomic prediction. And your assessment. What is the single fundamental action that a large language model is always performing, which we call atomic execution? The single fundamental action is predicting the most likely next token, or piece of a word, to come after the sequence of text it has already seen. It builds entire sentences and paragraphs by stringing thousands of these individual predictions together.
Welcome to Lesson 6.2, Invoking External Tools. Let's go back to our painter. She needs a very specific shade of blue that she doesn't have. She stops painting, walks over to a cabinet of pre-mixed paints, her tools, grabs the exact blue she needs, and returns to her canvas. When an AI stops generating text to call an external tool like a calculator, it's doing the exact same thing. This is tool invocation. Our learning objective is to identify how and why an AI invokes specific external tools to extend its capabilities. An AI has limitations. Tool invocation allows it to overcome these weaknesses. Modern AIs are trained to recognize when a prompt requires a tool. Instead of generating the next word, they generate a special structured piece of code called a function call. For what's the weather in London, the AI might generate get weather city equals London. The system runs this code, gets the result, and feeds that information back into the AI's context window so it can formulate the answer. Let's do an activity. For each prompt, state whether the AI would need to invoke a tool or answer from its own knowledge. Who was the first president of the United States? What is the current price of a share of Apple stock? Tell me a story about a dragon. What is 87 multiplied by 143? For the first president, no tool is needed. For the Apple stock price, a real-time data tool is essential. For the dragon story, no tool is needed. It's a creative task. For the multiplication problem, a calculator tool should be used to ensure accuracy. And your assessment. In simple terms, describe the steps that happen when an AI decides to use its calculator tool to answer a math problem. First, the AI reads the math problem and recognizes it needs a calculation. It pauses generating English and instead generates a special structured piece of code called a function call, like calculate 87 times 143. The system runs that calculation, gets the answer, and feeds that number back to the AI. Now that the AI has the correct result, it can give the final answer to the user.
Module 7, Continuous Improvement, Feedback and Evaluation Loop. A system is only as good as its ability to learn from its mistakes. This final module explores the most important part of the control hierarchy, the feedback loop that flows from the bottom all the way back to the top. Welcome to Lesson 7.1, The Role of Feedback Loops. You've built your ship, and it has completed its first voyage. When it returns, the captain provides a report. The destination was correct, but the ship was slow. This report is feedback. A smart ship owner would use this feedback to upgrade the sails. This process of using results to improve the original plan is a feedback loop. Our learning objective is to explain the importance of continuous feedback and evaluation in ensuring an AI system's ongoing alignment with its strategic intent. A feedback loop is the process of taking the output of a system and using it to make future versions better. In AI, feedback flows up the hierarchy. A bad answer, atomic execution failure, might lead to improving the AI's persona. A tool failure might lead to improving the system architecture. A systemic failure, where users complain an AI is giving risky advice, might lead to changing its guiding principles or even its core strategic intent. This commitment to continuous improvement is key. Here is an activity. Imagine our Recipe Finder AI frequently fails because it suggests recipes with ingredients the user doesn't have. This is a failure at the bottom of the hierarchy. What is one change you could make to a higher layer to fix this? Based on that feedback, a change could be made to its core directive. A new, better directive might be, first, list the recipes that are a perfect match. Then, before showing the steps, ask the user to confirm they have all the required ingredients. This directly addresses the failure based on feedback. Your assessment. In simple terms, what is a feedback loop, and why is it essential for creating a good AI system? A feedback loop is the process of learning from successes and failures. It's essential because no AI is perfect at first. By collecting feedback like user complaints or technical errors, developers can go back and fix the AI's core design, making it smarter, safer, and more useful over time. It allows the AI to evolve.
Welcome to our final lesson, Lesson 7.2, Implementing Evaluation and Self-Correction. A great ship captain doesn't just wait for the voyage to end. They are constantly checking their instruments and listening to the engine. They are performing ongoing evaluation. If they hear a strange noise, they might try to fix it on the spot, a form of self-correction. The most advanced AI systems are being designed to do the same. Our learning objective is to identify methods for evaluation and the concept of self-correction in AI systems. We evaluate an AI using human raters and automated tests called evals, but the frontier is AI self-correction. This is a workflow where the AI generates a first draft, then pauses to critique its own work based on a directive like critique this response for accuracy. It might say the first point is good, but the second point is unclear. Then based on its own critique, it rewrites the draft to produce a better final answer. This is a mini feedback loop that happens in real time. For your activity, you ask an AI to explain photosynthesis. It gives a very technical, jargon-filled answer. If this AI had a self-correction mechanism, what kind of critique might it generate about its own first draft? The AI's self-critique might sound like this. This answer is technically correct, but it is too complex for a beginner. It uses scientific terms without explaining them. The response needs to be simplified with an analogy to be more effective. And for our final assessment, what is the main idea behind AI self-correction and why is it so powerful? The main idea is to have the AI critique its own work before showing it to the user. It generates a first draft, analyzes it for flaws, and then generates a final improved version. It's like having a built-in quality checker, allowing the AI to catch and fix its own mistakes in real time, leading to much higher quality answers. You have now completed the master course on the control hierarchy, from the high-level strategic intent down to the atomic execution of a single token and back up through the crucial feedback loop. You now possess a complete mental model for understanding how purposeful modern AI systems are designed, built, and improved. Thank you for joining me on this journey.